Probably a good thing is just the defining of line symmetry.
I'm going to take out my highlighter. I like highlighting things. Rotation symmetry. Could you take an object, turn it, and have it look exactly the same as what you started with? Can you see that if you took this point right here and I turned it so it ended up right there? If someone would look at it, they would say nothing's changed. It looks exactly the same as you started with. That makes it rotation symmetry. Can you see that I could have also taken this point and rotated it all the way to there? It would be exactly the same. In fact, I think on my computer program here, I can I'm going to try to trace the outside. Okay, and I'm going to add a red dot. Row. All right, I'm going to move it over here. I'm going to move the red dot to the top there. I'm going to group those together. Right, that matches up perfectly with our shape right there. Now I can take it and rotate it. Bing, matches up perfectly right there. I can rotate it again. Bing, bing. Oh,
Not quite.
not quite. I got a little. It moved on me a little bit. Oh my goodness. Trouble. Trouble. Oh, I see what's happening here. Oh. There we go. Matches up. Bing, bing. Oh, I like that one. It's not right in
Yeah,
place.
it's not right.
Bing. Bing.
How many times?
And then right back to where we started. Woo. So we're going to say stuff about this. This one has rotational symmetry. We're going to talk about how many or what the order of rotation is and what the angle of rotation is. And this is what makes it a little bit more mathy than the last one. Okay, so first thing to highlight here. The number of times a shape coincides with itself is the order. So how many times does this one take before we get back to where we started with? 1, 2, 3, 4, 5, 6 times. So we would say that the order of this one was 6. I'm definitely thinking you're going to want to put this formula on your formula or your cheat sheet. It is the angle of rotation is 360 degrees divided by the order. That's going to be a very important formula that we're going to use and we're going to answer questions with.
Sounds like we should, at the same time, be putting that exact thing onto our cheat sheet.
So if we go back to this shape, this one that was right here, we could say that its order is 6. And its angle of rotation is 360 degrees divided by 6. Can you do that mental math, or do you need a calculator?
60?
It's 60 degrees. And so that means that if I took this second point here, I'll do it in red as well, and went to the center, and I joined that first rotation, this angle right there is 60 degrees. Do you know why the formula has 360 in it?
Because like a circle is
A
like...
whole circle's 360 degrees. Check this out. 60 plus 60 is? 120 plus 60 is? 180. Does that make sense? We're halfway around. Plus another 60. 240 plus another 60. Plus another 60. 360 all the way around. So you can see how using the order of and dividing 360 by that gives us the angle of rotation. And the angle of rotation is the minimum you'd have to turn it before it matches up again. So here's like sort of the calculations are done for you. So I guess technically you could say, well, everything has a rotational symmetry of 1, because if you rotate it at 360 degrees, it's right back to where you started with. But if the order of rotation was 2, 360 divided by 2 is 180. And so this is just the math done. We figured out this one was 6 to be an angle of 60 degrees. What about the letter S? Would you agree that that has an order of 2? Okay. Again, to see it, I'm going to trace it. Just because it's super fun to trace it. And put a red dot on that corner. Oh my goodness. If it has an order of 2, I should be able to rotate this and have it match up. Okay, obviously it's not matching up, but oh yeah. Look at that. Now that red dot's in the bottom corner. Matches up perfectly. That's 1 time. And then do I get back to the original? That's 2 times. Okay, so that makes the order 2. And in this unit, if you want, I have tracing paper. And you can actually draw something and take it and turn it to actually visualize it, if that helps you. Right? How many of you could, like, it's a skill. Can you take that and actually, with your head, turn it and see it match up? Or is it super helpful when I actually take it and turn it that way? That's helpful, right? Like, that's helpful to see that. But it's a skill to be able to turn it in your head and see it that way too. And so this would have an angle of rotation of 2. Okay, so questions A, B, C, D, E, and F are for you to try. You have to see what you think the order of rotation is and write down the angle of rotation.
Can we use our calculator?
You can use your calculator. Does anybody want tracing paper? I can cut you a piece. Yeah? Okay.
What? checking to see if you got it.
Got it.
And what's the order of that?
I'm trying to figure it out.
Look at it.
That's fair enough.
Then you don't got it yet.
It's
Anybody else want?
Yeah, and look at it. 1, 2, 3, 4. Just count the vertices. How are you
So then you can trace the shape on your paper.
Where did you get that from?
What?
Why remember that
You okay?
it's 360.
Oh, do you want some?
So this is the order. I would do this. I'd be right here.
Jaden, you want some tracing paper? Nope.
I'd be right, right?
You want some paper?
Oh, I already
So
got
order
it.
is 4.
You already got it?
Is 360.
This one is right. This one. Depends if you count the colors or not. Like if you count the colors, then when you turn it, the colors don't match up anymore. So then it would have none. And this one
Right, if you.
has line symmetry, but if you rotate it 180 on the short side, the left side, I don't think it matches.
So it's 360 divided by 4
That
because
one's gonna be none as well.
the angle rotation is
So you, and I want you to say the order and the angle. You've just written down the angle.
here, it's 2, so it is 180. Because 360 divided by 2 is 180. So that one you got
I'm
right.
gonna pause the video just while you guys are working. The first one, did you get an order of 2 and an angle of 180 degrees?
Yeah.
Well, then
There
you nailed
is
it.
the 1, and there is the 2, right back to where it started from. The second one, did you get an order of 4 and an angle
Are you
of 90 degrees? Let's check it out.
I'm waiting.
1,
Yes, have you been hearing
2, 3, and right back to where we started with 4. 4 times makes an angle of 90 degrees. Next one. Did you get an order of 1 and an angle of 360 degrees? Because technically, look at this. I know it sure looks like it's symmetrical this way, but now the white matches up with the black and the black matches up with the white. It's technically a different color,
Yeah.
right? So this is part of what makes this shape, people like this to look at, because it's like, it feels like it has the rotational symmetry, and if you just did the outline, it would, but the colors change, so it has kind of a little bit different that way. And this one we did already. Its order was 6, and rotation was 60 degrees, so I don't have to flip that one around again. Did you get this one had an order of 5?
Yeah.
And an angle
72.
was 72 degrees. It's kind of nice that we have that cheat sheet, but let's check it out. Here is 1, 2, 3, 4. Hey, this is kind of interesting because the shape itself, for my rotation, I'd actually have to see well, I have to move it this, oh, it does match up perfectly. But the program right now is not picking the center perfectly for me to rotate it. And the last one, an order of 1. This one's super tempting. It's super tempting to say that it's going to have 2. But when I take this, there we we go. And I rotated so it matches up on the bottom. Uh-oh. That point on the bottom matched up. It doesn't actually match up, right? And it so has an angle of 360. So we'll keep working with rotational stuff tomorrow. I'll stop the video here.